So this lesson we're looking at how we can model lines in 3D space. So it's like in regular 2D coordinate geometry where all you need is two pieces of information to be able to model a line. So in our case we could have a point and the direction vector, or we could have 2 points, and that would be sufficient to model the line. Now for this course there's three ways in which we represent it, or three forms. There might be more outside, I'm not sure. But first one we look at, which is my go-to, is the vector equation. Basically it's simply a position vector followed by a direction vector, and then you have a constant over here which we typically classify as a real number, but moreover when we're defining this we use the Greek alphabet by convention, so lambda, or you can use mu. If you go down you have a parametric equation. It's just the same as a vector equation except you've broken it out into its x, y, z components, and then you define that guy there. And then the final one, which is not my favorite, but there's actually really decent application to it. You've got the Cartesian equation. So have a look, you've got the lambda over here, which is your constant, or sorry, not your constant, your varying or your variable. But have a look at how this guy is related to these ones. What do you notice, Patrick? Let's look at the parametric instead. Think about it. Rearrange each parametric in terms of lambda. What would you get? Cartesian form. So to move between the different forms, you just rearrange in terms of, say, lambda. So they're all equal to lambda here, or you can just arrange them into x, y, z. Just is what it is. So let's have a look at the application here. Suppose we have two arbitrary points in space which we want to force a line to pass through. Point A, where is that, Patrick? Where is it? Point A. And yeah, I remember that place. Leishman, point B, whereabouts is that?
1, -3, 5.
5. Okay. What we're going to do is we're going to model a line that passes through points A and B. We'll start off by putting it in its vector equation. We'll then break it into its parametric form, and then we'll finish up by putting it in Cartesian form. Once we've done the theory to it, we'll have a look to make sure that it actually works using GeoGebra, and then I'll show you how to do it using your graphics calculators, which you may or may not find helpful. Alright, first part. We need to know a point and we need to know a direction. How do we find the direction for the direction between A and B? Just the direction vector. So it's going to be OB, take AB, or OA. That's going to be 1, -3, 5. Take 2, take 7, take -4. Hence, do we want to use points A or point B for our vector equation? A or B? A. Alright. So modeling this as a vector equation, we just say line R is equal to point A, which is going to be 2, 7, -4. Do we want to use lambda or mu? And your direction vector is -1, -10, and 9. Any questions? Perfect, you understood all of it. Okay, next one we want to do the parametric equations. is equal to 7 plus negative 10 lambda. Z is equal to minus 4 plus 9 lambda. And lambda happens to be a real number, and I should have defined that here. So that's parametric, and final one is Cartesian form. Cartesian form having its own application, even though not looking the best. Okay, Cartesian form is going to be x take, and what's it going to be take, Patrick? 2 all over negative 1. Y take 7 all over negative 10. And then Z plus 4, although to be honest, sometimes it's easy to leave it in that form. All over that, where you don't have to define lambda in this one. Vector form and Cartesian form. Sound fun? Okay, so let's have a look at how this visually appears using old mate GeoGebra. So, point A and point A, where did we say that was, Patrick? Negative 4. And point B, whereabouts did we say that was?
1, negative 3.
Okay, so you got 2 points A and B there. The direction vector between A and B, we'll just call it A, is going to be A, B, like so. So there's your direction vector. And modeling your line, like this. The line R is going to be point direction vector. So A followed by little a. There we go. So it passes through both points. Or if you want, you can put B. It doesn't make a difference. Seem cool?
What would happen if there was no lambda?
If there was no lambda, then we'll get to that in the next lesson.
Can you just like click there and do a backspace and see what happens?
What do you reckon is going to happen?
Oh no, they're just gonna.
If I take lambda out of the equation set, do you remember how we have y equals mx plus c?
It's just like.
Where there's always there's always an x and a y.
Yeah.
So what you're doing is you're ticking through different values of x to change the value of y. What we're doing here is we tick through different values of lambda to change the values of x, y, and z. Seem okay for now? It will make more sense when we get into the application of the lines in 3D space. We're just modeling at this stage. Alright, now final one is the graphics calculator. Could you guys open up your graphics calculators, go down to the bottom and go to 3D graph. You could press L, but it might depend on your firmware. Just go to 3D graph and hit enter. Should bring us to this trusty screen here. Next, what we're wanting to do is we want to clear the memory by F2 and just delete whatever's in there. I've got nothing, because I've already got rid of it. Next, we go to type, so F3. And then we want to go to a line because we're only doing lines at the moment, so execute. And then you've got 4 options, although you really only have 3. First one is express. This is Cartesian form. So you can put that in as it's shown over here. One after that, you have vector form, where you're putting it in like it's shown over here. You can do point and vector form, which is just another variety of vector form. And then finally, you can do 2 points, where you're not actually putting in a line, you're just putting 2 points and it will do it for you, which is pretty convenient. All right, let's go for express form. So XO, YO, ZO. In this case, it's going to be 2, 7, and plus 4. 2, 7, and then, sorry, negative 4. Then downstairs for the denominators, we have minus 1, minus 10, and 9. Press F6 to put it in memory, and then you can just draw it. Okay, and there we go. It gives us a not so useful illustration of the line in 3D space. But we're not using this tool because we think that the line is beneficial to look for. Rather, we're using this tool because if we have multiple lines, we can see for ourselves whether they've got a relationship such as parallel, perpendicular, or if they have an intersection, we can see the location at where they do intersect. Seem okay? Awesome.